Alright, so we started off by inputting a switch onto the top design, and all we did was turn off the hardware and change the drive mode to resist the pull down so it can open and close. So then we finished that and we went to the encoder or the quad, and we double clicked and we changed the counter size to 32, and we changed the counter resolution to 4x so it can move quicker. And we used the index input. We turned that off completely, and enable glitch, we turned that off as well. And then that was it for the encoder. So moving on to the sensors, we put in, for the LCD that was already programmed, but for C1 and C2 on the encoder, we programmed it to be 6 and 5 for the PSOC, and we turned the switch to 7. So for the program itself, so we turned the quad, which is the encoder, on, and the LCD, which was already on, and we made an integer count. Then we did a little equation right here for count encoder to get the counter so it can get the numbers, and then it'll display on the LCD and it'll print number count. So whatever number we switch for the encoder, it'll print that number on the LCD.
How we turn the switch to get the number that we desire by using this here. And as you can see, the numbers on the LCD screen either increase or decrease. So that would mean that our product and our code is correctly implemented. And again, now we're going to focus on the analog sensor. So what the analog sensor consists of is the ADC SAR program with the potentiometer connected to it and implemented. So just to talk about a few things, the configuration of SAR, we changed the resolution to 12 bits as well as the input range. We selected single-ended, but it changed once the code was ran and programmed. Now, as far as the sensors go, as you can see here, the pin 1 and switch 1 would switch to port 4 and port 7 to make the program run efficiently. As far as the code, we just added the integer implementation for the potentiometer here, as it is highlighted already, as well as the SAR sequence, which we are to wait for the results. So to talk more about the SAR, for the numbers to be inserted, to be converted, and then the for loophole, which is here. Once the program receives, it gets the result, gets the counter, and then implements the equation, clears the display, gets the position, and then prints the number that whichever the potentiometer, whichever way it goes, left or right. So the biggest difference between the analog and the digital sensor is that potentiometer has a certain range it hits. So it goes up to, what is that, 4095, and then it goes down as far as about 32. So that is our Austin Labria's project, both for the digital sensor and the analog sensor. Really good project. We enjoyed both, and thank you for the semester, Doc.